Welcome. This screencast is meant to show students in a Calculus 2 class how to graph parametric curves. And we should talk about what parametric curves are. So by definition, if x is some function of t and y is some other function of t over some interval of t values, then the set of all points x, y, which is the set of all points f of t, g of t, is a parametric curve. Well, why do we call it a parametric curve? Because t is the parameter. And the x equation and the y equation are called parametric equations for the curve. So when you were in high school, you set things up where you learned how to graph y equals 2x plus 3, and you had this chart, and on the chart you had an x value and a y value, and certain values of x you got to pick, and then y values were determined. Well, in this scenario, you get to pick the t values. You can pick them. They are the parameter. So t is the parameter. So you get to pick values for t, and then those values of t determine x's and y's. And then instead of getting an output, you get a point that's the output. That's the idea here. So if I may, let's sketch x equals 3t minus 1 and y equals t squared minus 1 for those t values, t ranging from -3 to 3. So how does this work? Well, you set up your t's and your x's and your y's, and your t's run from -3 to 3, and then you take some time and you figure out what the x's are for those t's and what the y's are for those t's, and then we graph those points in the coordinate plane. So take a moment and do that. I'll do that also. And the y values. And so then there are 7 points to graph. There's stuff from -10, 8, all the way to 8, 8. It seems to bottom out at -1, -1. And so you get a curve that looks like this. Time moves from -3 to 3. We do generally think of the parameter t as time. Time moves from -3 to 3, so the graph moves with that orientation. And you're saying to yourself, well, it kind of looks like a parabola. And I kind of agree. Because if x is equal to 3t minus 1, then t is x plus 1 over 3, which means that y is x plus 1 over 3 squared minus 1, right? Y is t squared minus 1. So y is t squared minus 1. And this is definitely a parabola, and in fact, it's this parabola. But only for t values between -3 and 3. So there is an initial point here. This is the initial point. And there is a terminal point here. We don't put arrows on the parabola to indicate that it goes forever, because it doesn't. The curve starts here and stops there. One more. One more. Let's sketch. Let's sketch x equals 6 cosine t and y equals 6 sine t for t in the interval from 0 to 2 pi. Well, you go ahead, pick your favorite t's, and decide what the x's and y's are that come from that. Pretty sure we know how this goes. And you get 5 points. You get 1, 2, 3, 4, and then back again. Sorry, not there. 0, pi over 2, pi, 3 pi over 2, 2 pi. And it makes us wonder, well, what's the shape supposed to be? And you think that the shape is probably supposed to be like this, that it probably goes with that orientation. Well, does it? Well, you could ask your calculator. I have set my calculator into parametric mode because I'm using Inspire software. I do that under graph entry, but most of the 84s and 89s have a graphing mode button. You have a mode button, and for most of your life, the func for function has been highlighted, but there's also par for parametric and pol for polar. That's next week, and seek for sequence. I set it to parametric mode, and when you set it to parametric mode and you hit the y equals, you can enter parametric equations. Probably have to put a time sign there. And sure enough, this appears to be a circle centered at the origin of radius 6. Now, that shouldn't surprise anybody because we learned in high school that cosine squared t plus sine squared t is 1. Well, cosine of t is x over 6, and sine of t is y over 6. And that becomes x squared plus y squared is 36. That's a circle centered at the origin of radius 6. So we can graph parametric curves either by plotting points and seeing the relationship, or by using technology, and either way is just fine. I will do a few more examples in another screencast that'll help us to see how this is supposed to go. If you need a little extra practice there or just want to double check your abilities. And otherwise, I hope this has been helpful to you.